All right, cool. All right, well, it's recording on YouTube just in a kind of a weird kind of way. So let me go ahead and get started because I'm sure you guys have lots of stuff to do today. So on Monday, if you remember, we actually started Chapter 5, and Chapter 5 only has 3 sections that we were covering. It has more than that, but we only are doing 3 of the sections. And we actually talked about 2 of them on Monday. The first was just our rules about exponents, and I think everybody had seen them, but it's always good to review them, and maybe there's 1 or 2 that you might be a little rusty on. So that's what 5.1 was. 5.2 is when we talked about our polynomial functions, and this was kind of just a quick, easy review kind of section where we talked about, not review, but maybe just pulling all the information we've talked about together in one section. So we talked about linear, quadratic, cubic, quartic equations, and the odd and even and what those look like. So the homework for that should be pretty good. It's kind of just a little bit different of a section. And so then today we're going to talk about adding, subtracting, and multiplying polynomials. Okay, so again, this is probably something that you've done, but is good to just make sure that we're all on the same page and review our rules and make sure that we're all feeling comfortable with what we can do with polynomials. So the first thing that we want to know is, what is a polynomial? So you probably have all heard that word before. So a polynomial, just in kind of basic language, is when you have a set of terms that are being added together. So for example, this, if you have 3x squared plus 2x plus 5, okay, this would be a polynomial because it's each of these, like 3x squared, that by itself is called a monomial. So this is your like root words, right? Monomial. I'm pretty sure, I'm not a language person, as you guys know, but the mono is the one, right? Monomial, and poly is multiple. So monomials, you add them together to get a polynomial. Okay, so that's where that word comes from. Polynomials, is kind of the general word, is polynomials. Under polynomials, we have, quadratics is one type of a polynomial. We have cubic equations and quartic and so on. So quadratic equations, cubic equations are subsets of polynomials. Okay. And so what we're going to do is we're going to review how can we add, subtract, and multiply polynomials together. So this is kind of a review section, which is always nice. And the first thing that we're going to talk about is, I'll just start over. How do we add or subtract polynomials together? Okay, so this should be pretty easy. So if I have t squared minus 6t plus 2 plus 5t squared minus t minus 8, could you add those 2 polynomials together and simplify them? You think you could do it? So just a review, when you add or subtract polynomials together, you need to look for what we call like terms. So what I mean by like terms is that we have a t squared and a t squared. Okay, we have a negative 6t and a negative t. And then we have our constant. We have a 2 and an 8. So we're allowed to combine together like terms to add our polynomials. So t squared plus 5t squared would be 6t squared, right? Negative, I guess I should write this out a little more. If I were to rewrite these polynomials together, I would write t squared plus 5t squared minus 6t minus t plus 2 minus 8. So then if I added together t squared plus 5t squared, I get 6t squared, right? Minus 6 minus 6t minus t is minus 7t. It's a crazy 7t. And then add 2, subtract 8 is minus 6. Okay, so if I were going to simplify this, this would be 6t squared minus 7t minus 6. Not 70, 7t. All right, so does that look familiar to everybody? Yeah. Everybody else good? You can, I did put up a chat up there. And everybody's here. Okay, good. Hi, Anton and Otto. Yeah, so that should look familiar to you guys. I want to give you a quick, really is a very, very quick side note as to why you can add like terms together. So, for example, in this one that we just did, right, we added together t squared plus 5t squared. And why can we add those together, and why do we add them together like we do? Well, the reason that we can do that actually is due to the distributive property, because it's my favorite property, right? And you notice that if you're adding these two terms together, each of these terms has a t squared in common. Okay, so we're going to take out a t squared. So if I basically undistribute and I take a t squared out of each term, I'm left over with 1 plus 5, right? And 1 plus 5 together is 6, so this becomes 6t squared. So that's why t squared plus 5t squared is 6t squared, because it's because of the distributive property that we're able to add like terms together. So I always just like to remind people that's why we can do that. Okay. All right. So let's try another one, just to make sure we are all good. Let's do. Oops, I don't know what there. There we go. Okay, so number 2. I always write the wrong thing. I always forget to switch it back. Number 2 is 8d minus 3 plus 9d cubed. And then you see here we're subtracting another polynomial, minus d cubed minus 13d squared minus 4. So when you're adding, it's pretty easy. You just keep whatever sign you have out in front. When you're subtracting, you need to remember that this subtraction here applies to everything that's in the parentheses. So what that means is that if I were to rewrite this without the parentheses, it would be 8d minus 3 plus 9d squared. Okay, nothing changes on the first polynomial. Then I have to subtract every term in my equation. So it's going to be minus d cubed. Okay, and then it's going to be minus a negative 13d. So it's going to be minus negative 13d squared. Okay, and then minus a negative 4. So if I simplify this last part, it's actually minus d cubed plus 13d squared, because a negative minus a negative is a positive, right? And then a negative negative 4 is plus 4. So 8d minus 3 plus 9d squared. So now I have to go through and collect all my like terms. So usually what you do is you start with the highest order polynomial. So what I mean by the highest order polynomial, it's the one with the biggest exponent. So my highest order polynomial is I have a negative d cubed here. So negative d cubed. There's no other d cubed, so there's nothing to combine it with. Then I have a 9d squared and a 13d squared. So I add those two together. 9 plus 13 is 22, right? 22d squared. So that's my second order. Now I go to just my plain old d to the first power. I only have one of those. So plus 8d. And then last up, I go to my constant. So I have a minus 3 and a plus 4. So negative 3 plus 4 is plus 1. So if I combine these two together, I get negative d cubed plus 22d squared plus 8d plus 1. Okay? Everybody feel comfortable with that? This should be review, so I hopefully it's like, okay. I'm gonna check the chat here, see if you guys are chatting at all. Nope. All right, well, I'm gonna assume you guys are good. What I want you guys to do is try number 3 here. Okay, and if you can, type it in the chat once you get it simplified. So try to simplify number 3. And I'm going to start writing on here, but you try and put in the chat when you got it, okay? All right, so I didn't see anybody put it in the chat. Maybe it's just because we're on a different platform today, so you guys are not able to do it. But hopefully this is what you ended up with. You ended up with 8v to the fourth minus 3v cubed plus 10v squared minus 7v minus 4. So hopefully that's what you ended up with. If you want to, you can tell me yes, I did. Or if you're trying to figure out, what was I going to say? Oh, I know what I want to tell you guys. When you're writing polynomials, the the preferred way to write a polynomial is to write it from the biggest exponent, so the term with the highest order, to all the way to your constant. So that's kind of the preferred way to write polynomials. I mean, technically, if you wrote them in a jumbled up order, they would be correct, but it's not really the proper way. So, for example, this right here would not have been written properly, whereas this would have been written properly. So while you're doing your work, it doesn't take any effort to really do it. And in fact, it's probably easier to go from the biggest exponent to the smallest. So that's probably, I mean, it's just a good practice, good math practice to do. Okay. All right. So that's adding and subtracting polynomials. All right. Now we get to multiply polynomials. And you actually can divide polynomials, but that was kind of the rest of chapter 5. So we're just going to deal with multiplying polynomials. And once we got multiplying down, then we're going to move on to chapter 6. Okay. So there's different options for multiplying polynomials. Okay. So the first one, the first example that's up here, number 4, is kind of our easiest example that we have when we are multiplying a polynomial. This is called multiplying by a scalar, but this in effect is actually an x out front. But whenever you have a polynomial, so this polynomial is the 2x squared minus 5x plus 7, right? That's the polynomial. And you have a number out front that's just a single variable or a single number, then this is our kind of our easiest case scenario for multiplying polynomials, right? What I mean by that is if you just have a single value out here, whether it's x or if this was 3 or 100 or whatever it would be, then all you need to do to simplify this is to use the distributive property, right? So because this is a single value out front, then we can multiply using the distributive property in order to get rid of the parentheses. So in this case, I'm distributing an x, so it's going to be 2x squared times x minus 5x times x plus 7 times x. So you can see how I've distributed this x to every term in my equation, right? And then I just need to simplify. So 2x squared times x is 2x cubed. So remember your exponent rules, you're going to add the two exponents together. So it's going to be 2x cubed. And then 5x times, or minus 5x times x is going to be minus 5x squared. And then 7 times x is 7x. So these are our favorite ones because those are the easiest, right? Does everyone feel pretty confident that they could do that? Use the distributive property and do that. I have confidence in you guys. All right. Just one note, if you for some reason, so I don't know if it's in this particular section or not, but I think it's worth mentioning while we talk about it. So let me kind of make up a problem here. So if I had, for example, I don't know, 2x minus 5 times x squared plus 3. And this is an x squared right here. This is a 2. Trying to make it a 2. Okay. All right, and I wanted to simplify this. So you're going to have to use multiplication, and you're going to have to use the distributive property to get rid of those parentheses, right? The one thing that I want you to note, well, two things I want you to note. This 2x over here is kind of on its own until we deal with this part. So we can kind of deal with that separately. And the fact that you're subtracting, that means that that needs to go when you distribute. So what I mean by that is you could actually think of this as I'm adding a negative 5 times x squared plus 3. So a lot of times this will throw people off when they have like a subtraction problem there, but just remember that negative goes along with whatever number that is. So these two are written the same. So then when you distribute it, you can say it's plus a negative 5x squared minus, well, yeah, you actually don't even need the plus there anymore. You can just say negative 5x squared minus 15, and now your 2x comes back in play. So as long as you take this subtraction and make it negative and take it with you when you distribute, right? That means that that means that you've accounted for your negative when you're distributing. Hopefully I explained that right. So when you simplify this and write it, it would be negative 5x squared plus 2x minus 15. So take that negative along with you when you go distribute. Don't forget that guy. Okay. How do you guys feel about that? Done that? Got it? Olivia said she was good. Everybody's feeling pretty good about that. You guys can totally do it, right? Okay. Number 5. What happens when we do number 5? Does anyone know when they see number 5? Oh, I know what to do. Or you're like, I know what to do and I don't want to do it. Okay, so number 5, we have we have in parentheses y minus 7 and then times y plus 6 in parentheses, right? I always do that when I do that. Okay, we have y minus 7 times y plus 6. Okay, so how do we simplify this? Well, technically what you do to solve this is that you need to distribute the y minus 7 to both terms inside of here. So what I mean by that is you would distribute, it would be y times y minus 7 plus 6 times y minus 7. And then to solve that, what you have to do is you have to distribute each of these numbers again, and you get y squared minus 7y plus 6y minus 6 times negative 7 minus 42. And then we simplify and get y squared minus y minus 42. So technically that's how you would solve it. It's just like the problem above, except instead of distributing a single number, you're distributing y minus 7. Okay, but if you have back in your Algebra 1 days, okay, some smart mathematicians long ago discovered a shortcut so that you don't have to distribute and then distribute again. And they call that shortcut FOIL. Right? And we've talked about this before in class, but we call this shortcut FOIL. So when we have, so these are actually, so we were talking about polynomials. These two right here are actually binomials. So we had monomial, which means 1, binomial means 2, and polynomial means multiple, right? So when we have a binomial times a binomial, we can kind of skip this step of having to distribute and distribute again by using FOIL. So remember, FOIL stands for first, outside, inside, last. So in FOIL, what we do is we multiply our first terms together, which is y times y, which is y squared. Then we multiply our outside terms, which is 6 times y. Then we multiply our inside terms, which is negative 7y. And we multiply our last term, which is negative 42. So you can see what FOIL lets you do is it lets you basically skip over the middle step. Right? It kind of takes this out of having to do it, which is always nice when you get to skip a step. Plus, it means less chance for error, right? And then you just simplify and end up with y squared minus y minus 42. So we like FOIL, right? Okay, so one more example I want to do. Unless anyone wants to see another example of FOIL. Do you feel rusty on FOIL? You feel okay on FOIL? Cool. How's everybody else? Okay, yeah, I think I can FOIL. Maybe even just trying it will kind of... Sometimes it's like, oh, I don't remember. And then you try it and you're like, oh, yeah, I do remember. If you don't remember, let me know and I can always try it again. Okay. I want to do one more example and then we'll probably actually wrap up early today. Okay, so number 6. Let's look at number 6, which is missing a parenthesis on mine. So number 6 is w plus 4 times w squared plus 6w minus 1. Okay, so this is the question. Can you use FOIL for problem number 6? Can you use FOIL for problem number 6? So the answer is no. Wah, wah. All right, so we can't actually use FOIL. We only can use FOIL if you have a scenario that looks like this, where you have two binomials that are being multiplied together. Okay, and by binomials, I mean when you have like x plus, a times x plus b. Those are binomials, all right? This, we have a binomial multiplied by a quadratic. So we can't actually use FOIL. So instead, we get to use back to our distributive property. Okay, so the thing with these is they're not hard, but they're a long problem. It's kind of like our substitution problems where it's like, not my favorite, but it's not difficult. It's just not ideally easy. So what I'm going to do is I'm going to write this in a different color so you can kind of see what I'm going to do. So what you're going to do is you're going to actually distribute the w plus 4. You're going to distribute everything that's in the parentheses to everything over here. Okay, so what this looks like is we have w squared times w plus 4 plus, oops, I meant to switch colors. We go plus 6w times w plus 4 minus 1 times w plus 4. So what I've done is I've taken w plus 4 and I've distributed it to all 3 terms in my equations. All right? But now what do I get to do again? I get to distribute each of these again to get rid of the w plus 4. So w squared times w is w cubed. W squared times 4 is plus 4w squared, sorry. 6w times w is plus 6w squared. 6w times 4 is 24w. Okay, and then minus 1 times w is minus w minus 4. So then the last thing I have to do is combine these together, and I get w cubed plus 10w squared plus 23w minus 4. So that's what this would be rewritten as. And all of these things, all we're doing is we're rewriting the polynomials without parentheses. That's what we're basically doing in all these things. Okay, so yeah, so I think you guys should be able to try those out. See how it goes, right? It should be review, but if there's a spot that you're kind of like, oh, I don't quite remember, please let me know, and I'd be happy to go over another one on Monday. We are almost done. I did want to actually show you 2 quick things just so that we're gonna, I can't talk. We're gonna do them again on Monday, but I think since we have a minute or two, it's always helpful if you can see things twice. Like I like to be able to explain it more than once. So I just want to show you a little bit from chapter 6 just so that you're kind of familiar with it. And so you see it twice. But does anybody have any other questions on this chapter 5? So that basically wraps up what we're doing for chapter 5. All right. We're going to combine chapter 5 and 6 together. So you're not going to have just a chapter 5 test on its own. Okay. So let me know. I know you guys are all working on your test too. So I don't want to put too much homework this week, but I think you should be able to get those 3 sections done because the ones are really, actually these 2 are pretty easy sections comparatively. Okay, so I don't have any other questions. I just want to give you a quick intro to chapter 6. Again, we'll probably do it again on Monday, but I just want to let you see it more than once. Okay, so what we're going to be talking about in chapter 6 is called rational functions and radical functions. Okay, so where we're going to start with that is we're going to talk about basically taking the square root of a number. Okay, so when I talk about so we're going to be talking about rational and rational exponents and what that means. So let me take a step back. So if I asked you what the square root of 64 is, do you know what the square root of 64 is? And we talked about a little bit about this back when we were solving quadratics, right? We talked about taking the square roots and what that means, right? So really what this means is, I think many of you know this is 8, but what this really means is the square root of 8 squared equals 8. Okay, so the square root is kind of a way of undoing your exponent, right? So for example, if you had, 4 squared and you take the square root of that, then you're left with 4. So this idea of the square root basically is it's undoing your square. So in chapter 5, we're talking about exponents, right? And the root actually undoes your exponent. So I think everybody's pretty comfortable with this, or at least has kind of seen this before, right? This idea that your square root and then the square of a number have a relationship to each other. But what might be slightly newer is that we can also take higher level roots than just the square root. So what I mean is that you can also, let me think here. So the number 2 cubed is 8. Okay, so you can also take the cube root of a number. So if I took the cube root of 8, that would be like taking the cube root of 2 to the 3rd power, and that would be 2. Okay, you can take the 4th root of a number. So 2 to the 4th power is 16. So if I took the 4th root of 16, would be the same as the 4th root of 2 to the 4th power, okay, which would be 2 again. And it doesn't just work with 2s. You can take different level roots all the way through. So depending on whatever your exponent is, okay, depending on whatever your exponent is, depends what kind of root that you're going to take. So section 6.1 is actually called taking the nth roots, because you could take, in theory, you don't do it very often, but you could take the 6th root of a number. And I don't know a good, let's see, 16, 32. The 6th root of 64 would be actually 2. Okay, so you can take roots all the way, and so what they mean by the nth root is you can have different number roots, whatever they might be. So if I go back to my original thing way over here, and when you talk about these radical signs, right? When we talk about this, we call this taking the square root. So really what we're actually doing, and we don't write it, is we're taking the square root. So we actually assume that it's the square root by 2. Right? So because square root is the most common, it's the one that you learn first, it's this relationship with the exponent of 2. We don't actually write square root when we're going to do it, but what we're doing is we're taking the square root. Okay, but there is the possibility to actually take the 3rd root and the 4th root and the nth root and so forth. Okay, so I just wanted to kind of let you guys see that, so that when we talk about it again on Monday, it's like, oh yeah, we know that. If you go to, let's see, if you go to Desmos, and your TI calculator has the same thing. And you go to take the square root of a function, you can see that even calculators, they just kind of assume, oh, well, just the radical sign, that's just taking the square root, right? The square root of 64 is 8. Right, but then if you dig a little deeper into the menus and you go to functions, and is it under, it's under miscellaneous. Okay, under miscellaneous, you'll see that there's an nth root here. So you can actually take the, if I wanted to take the square root, I could, oh, and then I think I retyped over it. Oops, hold on, try that again. The nth root, so put that in here. So Now I've rewritten it with the 2 in there, right? But you could also take the cube root of 64. You could take the 4th root of 64, the 5th root, 6th root, and so forth. So those are all different things that you actually can do to a function. And the reason that we're showing you this, right, is because the roots, taking the roots of a exponent is actually a good way to kind of undo them, right? So way back, a couple weeks ago in their quadratic chapter, right, we knew that if we had x squared equals 16 and we took the square root of both sides, it undid the exponent for us and just left x, right? So square roots and taking roots is actually really helpful because it helps us to get rid of that exponent if we're trying to solve an equation. So that's why we care about them. Okay. Has anybody done nth root before? Or they're just kind of new? Okay. Anybody else? Like it's in there somewhere, or it's new? It could be new because sometimes people see it in algebra and sometimes not. Okay. Almost done, I promise. I will just tell you this, and then again, we'll kind of explore it more on Monday. So one last thing is that another way to, let's just add on to my page down here. Guess we aren't getting out quite as early, sorry. A little too excited about all this math stuff, right? All right, so we talked about the square root of 64, right? Or the square root of 81 or whatever it might be. And we said that that's just like doing the square root of 8 squared, or 8, okay? Another way to write the square root of 64 is actually 64 to the 1/2 power. Okay, 64 to the 1/2 power. And so then if I think of this and I simplify 64 to 8 squared to the 1/2 power, when you have a power to a power, you just multiply and get 1 and you're left over with 8. So again, if I go back to Desmos, and where is it at? Okay, there we go. And I have the square root of 64, right? If I do instead write this as 64 to the 1/2 power, oops, right? You also get 8. So another way of writing the square root is that number to the 1/2 power. So that's kind of a new thing, right? So then kind of extending that a little bit, if you are taking the cube root of, let's say the cube root of, we'll just say x, because it doesn't even matter what's in there. Another way that you could write that is x to the 1/3 power. If you're taking the 4th root of some number x, you could rewrite that as x to the 1/4 power, and so forth. So you can actually have exponents that are fractions, okay? And those fractions indicate that you're actually taking the root of an equation. Okay, so that's kind of how we can, one way that we usually, when you start off in your math class, whenever it was back in, I don't know, pre-algebra or before, you talked about square roots, right? But really what you're doing is you're taking 64 to the 1/2 power is another way you can think of it. And the reason that we care about that is because again, that's going to help us solve it. We're going to use our exponent rules to solve it. So, okay. Well, at least we're 5 minutes early getting out. um, like I said, you don't have to start on your chapter 6 homework yet. I would work on your test, obviously, and then chapter 5. But I just wanted you to see it because it doesn't hurt to see something twice. Kind of helps everybody stick in their brain a little bit better. So thanks, guys, for all coming in here today. And I will see you guys all on Monday. And in the meantime, if you get stuck on anything on your test or you're, need something to review, send me email and let me know. I'm happy to help. All right. Have a good rest of your Wednesday and a good rest of your week. Thanks. Bye.